All right, so we've gone through 1.2, or you're skipping ahead. Here's the important stuff, the CTS. Slope of position versus time is going to be velocity. Easy fact to remember, translating it between the graphs, just remember the time is the same. So the slope for the first 3 seconds gives you a velocity for 3 seconds. You could take that and plot it on the velocity versus time graph. If velocity is not changing, then you have a straight line for a position versus time graph, going away from 0, going towards 0. Velocity, if your velocity is constant, then on a velocity versus time graph, you have just a flat line. Area of a velocity versus time graph is position. This is also known as the integral when you get to your calculus. So to find your position given velocity versus time graph, find the area under the curve. Velocity is measured in meters per second with direction. So this is the vectors versus scalars. Speed is just a scalar. It's just going to tell you how fast. Velocity includes your forwards, backwards, up, down, north, south, positive or negative. So direction has to be indicated. Motion diagrams versus graphs versus equations. Motion diagrams are the little dots that are like a strobe light flashing once every second to show how the object is moving. If it's moving at a constant velocity, the equal spacing between them. If it's moving with an increasing velocity, then it starts out small and then slowly gets bigger and bigger. If it's slowing down, then it starts out big and then it goes small. Just remember that space between is the distance covered. Graph is going to give you a lot of detail. You can see the slopes going on. Equations are the best for sure. Graphs being probably the most common that we're going to run across. Derive means to show the steps. To do this, you're going to find two equations that share the same variable and set them equal to each other. This is fun. I promise you, once you get the steps down and the hang of it, you're going to say, this is so cool, because you can create your own equations, and that's what we're going to do in this class for the whole year. Create your own equations. Expression means an equation. So if we're deriving an expression, then that just means we're showing the steps to get to a new equation. Of course, we have our laws of physics, and everything is going to be governed by those. And we start out with our laws of physics, and then we apply them to each individual situation to come up with our own expressions. That's what we do in physics. So that's it. Practice, 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 practice.